Good morning, my dear students. Welcome to my physics class. Our today's chapter is circuit and current electricity. Let's start now. Our today's topic is electric current. At first, we will know what is charge. Charge is the fundamental property of elementary particles like electron, proton, etc. We know atom consists of electron, proton, neutron. These are elementary particle, and charge is the fundamental property of these elementary particles. We know the charge of electron and proton are opposite in nature, and there is no charge of neutron. Neutron is chargeless, and the charge of proton is considered as positive charge, and the charge of electron is considered as negative charge. That means there are two types of charge: positive charge and negative charge. The charge of proton is positive charge, and the charge of electron is negative charge. The unit of charge is coulomb, and it is the SI unit. Now we will learn electric field. The region around a charged body where it exerts its influence is called electric field of that charge. That means electric field is a certain region around a charged body or charged particle in which its influence is present. That is, this is the region around a charged body, and this region is electric field. That means if any charge is brought in this region, then this charge can attract or repel that charge. That is, its influence is exist up to this region. This region is called electric field of this charge. That is, electric field of this charge is this region. And if any charge is brought outside this region, this charge will not attract or repel that charge. So this region is the electric field. Now, electric potential. The amount of electrical work done to carry a unit positive charge from infinity to a point in an electric field is called electric potential. Its unit is volt. That means electric potential means amount of electrical work done to carry a unit positive charge. Unit positive charge means 1 plus 1 coulomb charge. Plus 1 coulomb charge from infinity to a point in an electric field. From infinity to a point in an electric field. Consider this is the electric field around this charged body or charged particle. And consider we will bring a plus 1 coulomb charge from infinity to a p point, and amount of electric work done to bring this plus 1 coulomb charge from infinity to this point is W. Then potential of this point V is equal to W. So potential means amount of electrical work done to carry or bring plus 1 coulomb charge from infinity to a point in an electric field. Here P point is inside this electric field, and to carry plus 1 coulomb charge from infinity to this point is W. So electric potential of this point V is equal to W. That is amount of electrical work done to bring a plus 1 coulomb charge from infinity to a point in an electric field is called electric potential. and the unit of electric potential is volt, and it is denoted by V. Now, potential difference. The amount of electrical work done to carry a unit positive charge from one point to another point in an electric field is called potential difference. Electric potential means to carry a unit positive charge from infinity to a point in an electric field is called electric potential. But potential difference means the amount of electrical work done to carry a unit positive charge from one point to another point in an electric field. Here A and B are 2 points of this electric field. According to this definition of potential difference, amount of electrical work done to carry plus 1 coulomb charge from A point to B point is the potential difference between point A and point B. Here from one point to another point in an electric field, amount of electrical work done to carry plus 1 coulomb charge, that is this charge, from A point to B point is electric potential difference between these 2 points. Consider the electric potential of A point is VA and electric potential of B point is VB. So their potential difference is VA minus VB, and this electric potential difference is the amount of electrical work done to carry this plus 1 coulomb charge from A point to B point. So potential difference is equal to VA minus VB is equal to W. Here W is the electrical work done to carry plus 1 coulomb charge from A point to B point. That means if we want to carry this plus 1 coulomb charge from A to B, we need W amount of electrical work. So this amount of electrical work done is the potential difference between these 2 points. So potential difference between point A and point B is VA minus VB is equal to W. Here W is the electrical work done to carry plus 1 coulomb charge from A point to B point. This is the potential difference, and unit of potential difference is also volt. Now electric current. Electric current means flow of electrons. We know electric current means flow of electrons. When electron flows from one place to another place, then we can say it electric current. If there is potential or voltage difference between two ends of a conductor, electron flows from lower potential to higher potential. That is, if we want electric current, that is flow of electrons, we need potential difference. There is no potential difference, there is no flow of charge, that is there is no flow of electrons. If there is potential difference or voltage difference between two ends of a conductor, electron flows from lower potential to higher potential. Here positive potential and it is negative potential. So it is lower potential and it is higher potential. This potential is due to positive charge, so positive potential, and here potential is due to negative charges, so it is negative potential, and positive potential is higher than the negative potential. So electrons flow from lower potential to higher potential. Here higher potential and here lower potential. So electrons flow from lower potential to higher potential. And if there is no potential difference between these two ends, then there is no flow of electrons. to, if we want the continuous flow of electrons, then we need to maintain the potential difference between these two ends. And if there is no potential difference, then there is no flow of electrons. So electrons flow from lower potential to higher potential. Always electrons flow from lower potential to higher potential. And for this flow of electrons, we need potential difference. So if there is potential or voltage difference between two ends of conductor, electrons flow from lower potential to higher potential, and this is the electric current. When electrons flow from lower potential to higher potential, then we call it electric current. That means flow of electrons is electric current. And here negative charge, we know the charge of electron is negative. So negative charge or electrons flow from lower potential region to higher potential region. Here positive and here negative end. That means there is a potential difference. Here positive terminal of battery and here negative terminal of the battery. And electrons always flow from negative terminal to positive terminal. If two ends of an electric source, that means battery, is connected by a conductor, electrons flow from lower potential to higher potential. That is, if we connect this bulb by a conductor with the two ends of a battery, then electrons flow from lower potential, that is negative terminal, to higher potential, that is positive terminal. Conventional direction of electric current is opposite to the direction of electron. It is taken that the flow of current is opposite to the direction of flow of electrons. So electrons flow from lower potential to higher potential, that is negative to positive, but conventional direction of electric current is from higher potential to lower potential. That is, current is flowing from positive to negative direction, but actually electrons flow from negative terminal to positive terminal, that is lower potential to higher potential region. But direction of electric current is from higher potential to lower potential. This is the direction of electrons, but this is the direction of electric current. That means you will remember it, the direction of electric current is opposite to the direction of flow of electrons. So direction of electric current is from higher potential to lower potential region. Electric current is denoted by I and its SI unit is ampere, and ampere is denoted by A. Electric current is denoted by I and its unit is denoted by A. A means ampere. Different types of electric current. There are two types of electric current. One, direct current or DC, and number two, alternating current or AC. DC and AC. There are two types of current, DC and AC. DC means direct current and AC means alternating current. Now, direct current or DC, if there is no change in the direction of current flow with time, it is called direct current. That is, with time the flow of current, direction of flow of current will not be changed. If there is no change in the direction of current flow with time, it is called direct current or DC. here current is flowing from higher potential to lower potential, and it is DC because current is always flowing in a certain direction and there is no change in direction. Current is flowing in this direction. As there is no change in direction, so it is direct current or DC. And here positive terminal is fixed and negative terminal is fixed. Current is flowing from positive to negative, so it is DC current. And this is the graph of DC current. Here DC current, the with time there is no change in direction of electric current. Electric current is always positive here. Now alternating current AC. When the flow of current changes its direction periodically, it is called alternating current or AC. In case of AC, the direction of current flow will be changed periodically. Periodically means after a certain interval of time change it will change its direction. And here AC or alternating current is flowing in this direction at a time, and after a certain time the current is changing its direction in this direction and again in this direction, this direction, this direction, this direction, this direction. Here flow of current is changing its direction periodically, so it is AC or alternating current. When the flow of current changes its direction periodically, it is called alternating current or AC. And this is the graph of alternating current. Here the current is positive and after certain time it will be negative and again it will be positive. That means it will change its direction. So when the flow of current changes its direction periodically, it is called alternating current or AC. And here the graph of AC and DC current. Here DC current, that is always it is positive and there is no change in direction, that is it is always positive, so it is DC current. The red graph is DC, and here 0 to 1 ampere, then it will decrease and it will be negative, and here minimum minus 1 ampere, then it will increase again, and here 0, then it will be positive, then after decreasing it will be 0 and then again negative. So positive, negative, positive, negative, so it is alternating current, and this is direct current, DC and AC. So the alternating current or AC changes its direction periodically, but DC does not change its direction. This is the main difference between AC and DC. And the frequency of AC in Bangladesh is 50 cycles per second. That is, in 1 second the AC or alternating current completes 50 cycles. That is, here from this to this is 1 cycle, and in Bangladesh AC completes 50 cycle per second and it is known as hertz. That is, frequency of AC in Bangladesh is 50 hertz or 50 cycle per second, and it varies from country to country. And then the frequency of AC in United States is 60 cycle per second or 60 hertz. So in our country the frequency of AC is 50 hertz, and in United States frequency of AC is 60 hertz. You will remember it.